To class today, we are looking at the theorems of circle. In our last class, we talked about the properties of circle. So today we are looking at the theorems of circle. So we'll take the first theorem, which say that a perpendicular line drawn from the center of a circle to a chord bisect the chord. So that is the first theorem. So the theorem states that a perpendicular line drawn from the center of a circle to a chord bisect the chord. So this is what we are saying in essence. That remember we said that a line drawn from any part of the circumference, let's say this is A, this is B. So a line drawn from any part of the circumference to another part of the circumference is called a chord. So this is a chord. Now, if this is the center of the circle, the theorem is stating that when a line is drawn from the center of the circle, perpendicular, meaning that by meeting it at right and meeting it at the center, like this, you draw a straight line from this middle down. Let's say this is point O. That this line bisects the chord. So, like this is a radius, this is a radius. So you have two radii. We can say that line AO is equals to line OB, and these are radial. Now when you have two radius, it becomes radial. These are radial. So we have that. So what the theorem is saying that it makes angle 90 bisect this line. So how do we prove that this is true? So we first of all look at if line AO is equals to line AB, line AB, line AO equals to line OB, making it what two radii, that is they are equal, it means we have an isosceles triangle. So but then we are looking at this. If line AB is a straight line, line AB is a straight line, you have angle 180 at this point, which is that point, and you have two lines bisecting. You have a line bisect at the middle. So to prove this, well, let's label this point M. So we want to prove that line A, to prove this, we prove that line AM is equal to line MB. To prove this, that line AM equals to line MB, because line AB makes what? A straight line. So let's prove and see. Let's see if this is true. Then we would have proved the theorem. So we need to prove that these two lines are equal. So if that is, so we have triangle AOM, which is equals to triangle MOB. Now we need to prove this. If this is true, then we have x dot A, that is we're having two angles. Now if we need to prove this, then we'll have to show that this, if that is true, then we have this. Remember that A, triangle AOB, the total sum of the angle there, we have 180 degree. So, and these two triangles AOM plus triangle MOB give us 180 degree. So we'll look at this. That is, this gives us sum of angles on a straight line. So we have this, that is true. It means that if these two are equal, we have this 2AOM equals to 180 degree. So we can change this to become, making this to be at the middle, that is triangle 2AMO equals to 180 degree. So we have 180 degree divided by 2. This gives us 90 degree. That makes it what? Perpendicular, which is what? Right angle.